So, we're going to try to find a value of a so that we can get a local minimum at x equal 2. Now let's go through again one more time. How do we know we get local maximum or minimum? We have a derivative that's equal to or undefined. And we have a sign change. In this case, if we want a local minima, we want a sign change of going from negative to positive. All right. So let's go ahead and let's find out about this derivative. F prime of x is equal to 2x. And now I have to take the derivative of a over x. A is acting like a constant here, so this is going to be negative a over x squared. So let me find out if I can set that equal to 0 and see if we can find a value for x. Oh, I'm sorry. We got additional information. We want the local minima to be at x equal 2. So let's go ahead and plop that 2 in there as well. Minus a over 2 squared equals 0, or 4 is equal to a over 4. You can put tails on my a's a little bit more. And that means that a must be 16. Okay, let's see if we can finish this job. So if we're at 2, if f prime is equal to 2x minus 16 over x squared, if we have a number that's way bigger than 2, this is big and positive, this fraction becomes pretty small. When x is 100, 100 squared is 1,000, the 16 over 1,000 is pretty small. It's going to be positive there, and negative on the other side. So we have that decline. We have the decreasing, increasing. So indeed, it looks like when a is 16, we get a sign change at 2, and the sign changes from negative to positive. Okay. How about point of inflection? When do they occur? Okay. Points of inflection are places where there's changes in concavity. Second derivatives is where we look for concavity. So when the second derivative is positive, it's concave up. When the second derivative is negative, it's concave down. And our point of inflection is where that concavity changes. It changes when the second derivative is equal to 0. So let's go ahead and take the second derivative and see if we can find a point of inflection. Or get a point of inflection at 1. Let's start with the fact that f prime of x is equal to 2x minus a times x to the negative 2. I'd rather take the derivative in that notation. Means f double prime of x is equal to 2 plus 2a x to the negative 3. Let's check to make sure that that derivative was done properly. Bring that down. Negative times negative 2 is positive 2. That's just a constant. Lower. Okay. That's good. Now, what is f prime at f double prime at 1? 2 plus 2a times 1 to the negative 3rd power. 1 to the negative 3rd power is just a 1, so it looks like I just get 2 plus 2a. And when does that equal 0? Let's bring the negative 2 over there. Let's divide by 2. And it looks like when when a is negative 1. Hello? I am. Hey. Yeah. Yeah. Okay. Not much. They they don't know about that at all. Right? All right. All right. Bye-bye. Okay. All right. So let's go back and do the same thing we did with the other earlier one, and that is, let's look at f double prime. Let's look at it as we're passing through 1. And again, when we're passing through 1 with a is equal to negative 1, we get 2 minus 2 x to the negative 3. When x gets really, really big, this number gets closer and closer to 0, and this ends up being positive. But when we get really close to 0, this number gets really, really large and positive, but then you multiply it by a negative number. On that side, it's negative. So there is a sign change in the second derivative at 1. Therefore, there is a point of inflection there. Right? And that's problem number 33.